This is another episode of the Masters of Beautiful Achievements. What can we learn from them on how they apply natural science, systems thinking, and personal leadership to realize these beautiful achievements? These conversations are made possible by our Patreon and Gumtree community, so I want to thank each of you for your monthly or even your one-time support. Your contributions enables me to create these amazing conversations, so thank you for your support. When you're not a member yet, click on the links below to join and be part of this amazing community. If you're interested in how I can help your business create beautiful achievements, choose one of my Gumtree offers on how you want to engage with me, or contact me directly via Scope Matters website. And now, it is time to enjoy the conversation with today's masters. So, good afternoon. Today I have a special guest. His name is Marnix ten Kortenaar. He's a Dutch innovator and has been very busy since he started his company Dr. 10. And I'm really, really honored that you, Marnix, are here today.
Thank you so much.
Based on your background, Marnix, I'm really curious, how did you end up being an innovator with so many innovations you've already been creating?
Well, it started in the usual way. I just did a study and I did another study, and then I finished my study in chemistry and physical chemistry at the University of Delft.
Mm-hmm. That was your PhD, is that correct?
Yes, I did a PhD in Delft. But I was always kind of a more creative, broader scientist, I would say.
Mm-hmm.
And then I started working in some big companies, and I worked for the university. And then I think it was in about 2008 that I felt like, okay, I've gained some experiences in science, in technology, in water, in energy, in food. I worked for a food company, I worked for a chemical company, I worked for an energy company, and I also used to be a speed skater, a sportsman, dealing with ice and ice innovations. So I was also related to the subject of water. And I remember in 2008 I was in a job in a chemical company, which was a kind of a more standard job where I could be a good house father with a good salary and a car and everything organized well. But somehow I felt like, okay, I'm working now on a subject that doesn't really need a PhD guy or somebody that is going a bit deeper into the world of science. And then there was a boss, and he said, well, I think we prefer to transfer you to the R&D department in the south of the country. And I felt like, oh, but that's not what I want and what my wife wants and our children that were just being born. So I felt like, okay, what should I do? I should either go back to university or I should start a company.
That's not a decision you take very lightly.
No, it was a very difficult period because I was also in a personal transition where I was kind of, more, looking again for God and for the position of God in my life and question also how God, could be in my life. And exactly in those days, I went to Africa.
Oh, wow.
Yes. And I was there and we helped with some youngsters to build an orphan house, and it was a charity project. It was a great project. We wanted to do something good for some other people rather than just earning your money and living your life in a standard way. And while being there in Africa, I realized that I should not go longer the road of the multinational, but that either I should go back to university or back to a company. So then when I got back in 2008, I realized, okay, I don't know what to choose, but I will choose both. So I was able to get a part-time job in the university, and then At the same time, I was able to start up the company, and the multinational gave me some golden handshake, so I had a little bit of money to start in a startup. And then I think it was within 1-2 years that the university decided to cut budget and that all temporary people had to leave their job. So somehow I ended up in my own company, which was a startup, but already kind of got money then from the government and got money from customers. So we kind of started to grow. It was a classical startup, like any other startup, nothing special. Although the view and the thoughts and the ideas that we got were, I think, at least in those days, very special. So,
yes, because that I noticed on your portfolio, which I could see on your website, there was quite interesting directions of finding solutions for the problems we have.
Yes.
In food, sports, energy, and also water.
Yes, I was especially in those days.
Wait, when are we talking now? Around.
Well, we talk about 2008. It's 16 years ago. I was in Namibia, Africa, and I realized that Africa would go solar, that they would get more and more solar panels, and that wherever you were in Africa, I saw that people needed batteries. So one of the issues that popped up immediately was, hey, wait a minute, these people need batteries. And my Master of Science was about batteries in 1994. So 14 years after the master degree, I realized, wait a minute, I'm back in the same subject. But now I see the society relevance for it.
Mm-hmm.
And now I see also the need. And while being in Africa, I saw that that the people could basically only buy lithium batteries or lead acid batteries. And both were a problem for the situations they had, the high temperatures and so on.
I think you have to explain that, because most people, and me included, a battery is a battery. So what is what is the problem with those two?
Well, it was one of the subjects that came up then, but everybody probably knows that you can't put an iPhone in the sun.
Then it will blow up.
It will blow up. The lithium battery can't handle the high sunny temperatures that are outside. We were in the middle of nowhere in Namibia, and I was realizing, okay, if I put here in the full sun in the desert a battery, then you might get trouble with the temperature. That was one.
And the use, you never know how they're going to use that.
Yes, and there was another thing that I realized, that all those batteries needed electronics, BMSs, battery management systems, and energy management systems, and chips, and ICT, and electronics. And
when I was in Africa, Zimbabwe, the house I was staying, they had a car battery and a solar panel, and that's how they charged the battery. And on that, I could charge my computer.
Yeah, in that case, probably you saw a lead acid battery.
Yeah, I think so. Yeah.
And lead acid is also an okay battery that lives for 140 years, I think, something like that. It's the workhorse of the battery industry for long. Now, lithium is more or less taking over, but I also realized that lead acid had a negative, because both lead acid and lithium, by the way, you can't discharge them 100%.
Huh?
You cannot discharge the battery completely because they break.
Wow! How does that work? Because the thing is that, Marnix, I have my phone and it say 100% and it says 0.
Yes. In your mind it's 0, but the battery, part of the battery is not being used. And,
really?
Yes. You can see it as a bucket of water. Battery is basically a bucket of water.
Mm-hmm.
You put in water, and when you need the water, you empty it. And I realized that the whole battery industry was using buckets that could could only be poured out or could be emptied up to half of the bucket.
Oh, really?
Yes, so that was another thing that I started realizing, okay, wait a minute. And then they needed all this electronics and BMS and stuff.
That is so inefficient.
It is inefficient. And it is also, there's a lack of using materials. Basically, you don't use 20, 40, 50% of the materials.
But it means that with charging and discharging, the anode and cathode get polluted and they're not functioning very well. Is that correlated to each other?
Yes, that is, if you discharge the battery, yes, you get all kinds of side processes that cause the battery to decline and to give up its life. Another problem I saw there in Africa, for instance, was that all batteries were not able to be connected to solar panels directly, because solar panels create a voltage that runs between 0 volt and, let's say, 35 volt, 40 volt, depending on the solar panel. And then I realized, wait a minute, which battery can charge between 0 and 40 volt? And then I saw that the big workhorses of the battery industry, lithium and lead acid, couldn't do it. So
you have to put an inverter in between or something.
Exactly. You need electronics in between that make the right voltage out of it. And that voltage can be absorbed by the inverter that makes it into DC or in AC current. So standing in the middle of nowhere in Africa with some people that didn't know electronics at all and no ICT at all, I thought, okay, wait a minute. We should go back to the root of battery science. We should travel back to 1880 and we should reinvent the battery. We should find the battery for these African people.
Yeah, because one thing I've learned is that in was it 1850 or something, there were already electric cars in America driving, and the biggest issue was the battery.
Yes, but the root of battery science was there were a few batteries that were chosen for a certain reason. There was the Electron cell, there was the lead acid battery. 100 years later, more or less, the lithium battery came. So I realized and asked myself, why did all these battery scientists that lived for so many years in this subject, why did they choose these chemistries? And why the world ended up with lithium and lead acid? Is that smart? And is that
that's a very good question.
Yes. So this is the question that came on my desk there at that orphan house in 2008. And I realized, well, we need here a battery box that simply works, that charges forever, that can discharge 100%, that uses abundant green, low-cost materials, and that can be produced in an easy way, and that can be connected directly to a solar panel, and that can stand outside in the heat or even the cold of the area.
Yeah, because the cold is also an issue for the current batteries.
Yes. So I kind of attached to the developments of 1880, 1870, 1890.
Really, you really went back to the origin?
Yes, because I'm a chemist, and I started looking at the periodic system of elements, and I thought, okay, wait a minute, what is a battery? It's a plus and a minus. You need some elements you have some possibilities on the left, on the minus. You have some possibilities for an electrode on the right, on the plus. You choose some kind of electrolyte with some kind of salt, and you have a couple of options. You can also replace water by an organic liquid, but it was a matrix in my head. It was like, okay, you have maybe, in my mind at least, I thought you have let's say 10, 20 options on the left, 10, 20 options on the right. let's say, a couple of electrolytes that could work. And so I thought, okay, if it's a 10 times 10 times 10, then there's 1,000 options to get into a new chemistry, to get into a new battery.
Yeah.
So when I got back from that trip, we got some money from the Dutch government, and I could start to do R&D again. And I went more or less back to the subject that I'd done 14 years before. However, in those days, there was not only the problem of salt, but there was also the problem of water. We saw that in Africa, there was a lack of clean drinking water on many spots. So we also got a project in those days for solar desalination, for purifying salt water, seawater.
Yeah. Mm-hmm.
So I went literally into a garage and I bought some equipment and I started doing experiments and experiments and experiments and experiments. And the Dutch subsidies and some customers kept me alive, and I could get an income. And we just worked for years, let's say at least for a year, maybe 6 years, to a point where we had new simple prototypes.
Mm-hmm.
In new chemistries. Different new chemistries were developed, and also a solar desalination system was developed. And then from that point, people said, okay, now we will give you an innovation prize. And there were people saying, okay, get that into production and outsource it. And, yes.
Hurry, man.
Hurry, yes. Can sell shares, become rich, blah, 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 blah. But reality was different. If you have a new product,
mm-hmm.
you also need a new production, and you need a new integration, installation, and implementation into society.
Yeah, you need all a new infrastructure.
A completely new infrastructure. So, in all the books of the economic people, we scored low because new product, new process, new market, new technology.
Marnix, those economics are all linear, and what you're saying is you require a more systemic approach.
Yes, so we had to go more or less a completely new road,
mm-hmm.
And then what happened was that in those years, there was about 2010, 2014, there were a few other companies trying to get new energy storage products. In North America, there were a few big guys.
Yeah, I know there was a big, what was it, sodium, also a salt battery company, but that went bankrupt, I think, a couple of years ago.
Yes, there was one by famous multinationals sponsored or set, and that went bankrupt. And then there was another one set by a big multinational. It also went bankrupt. And then later, there were a few powerful people that said, we will make a mega factory, a giga factory. They all said, we are going to do it. But they all bypassed the reality of reality, which is that not a lot of people realize that if you take the world of batteries, it took 150 years to make that battery world the way it is today.
And you mean then lithium as a standard or just general?
Yes, only 2 chemistries really made it to the market in 150 years of R&D. So by thinking, we take some millions and we invest it, and we take some smart professors and we take a group of people, we put them together and we just make them, grow a new tree, a number 3 battery is not that easy. And people didn't realize that. A lot of people think that you can buy everything with money. But high science or smart science or a creative idea, I think, is more kind of a serendipity or a gift of God. And
then you need to do the whole set up a complete new value chain. I mean, what I value from Tesla is that they understood that an electric car needs to go with a charging system.
Yes.
And even he had a solar business also to put that on the charging system.
I think Tesla and Musk did choose a right approach there, but it was not a chemical approach.
But that was more from a systemic perspective.
Yes.
If you want to introduce a new technology, it cannot go on itself. You need to introduce also the infrastructure all at the same time.
Yes.
Otherwise, it will not grow and accelerate the way you want it to be.
Yes, and what I also learned in those years was that, English is not my mother language, but there's a saying in Dutch that says, if you think twice at start, if you make a good start, it's 50% of the work. Mm-hmm. Now what you see a lot happening in the world of startups and new products and new innovations is that people have a great spark, they have a great idea, a great thought. But the first phase is the most crucial one, because you put your seeds in the ground, and if you put them 10 centimeters on the wrong spot, the whole tree will never bear fruits in the right way. So what you do see that most of the research projects nowadays are, high target, fast, making money projects. You have to score quickly. Mm-hmm. And there's not much time to make a good start. And
it depends. I also know enough innovations like yours in the battery that has a long lead time, and they have. It is so important to set up the right ecosystem, that you have people around you or companies around you that nourish you.
Yes.
Until you're ready to launch.
Yes. What you also see, for instance, with you saw it with the solar panels. I think solar panels were. It's a fairly basic product. You have n-doped silicon and p-doped silicon. You put them together and you have a plate and you have a solar panel.
Okay.
It started in the 80s with cost prices that were much higher than today. And it took years and years and years up to the day of today, let's say 30, 40 years before it became a big industry with mass production worldwide. Even in the days where we have money, where there's fast communication, it still took years and years and years to come to the cost price of products that we have today.
Yeah, everything has to be reinvented.
Everything has to be reinvented. And the same you saw happening with lead acid, you saw it happening with the lithium battery. It took years and years and years to make them grow in a serious way. And then there's always people that think, if you put a seed in the ground and you make a tree grow and the tree comes up, maybe it grows faster when we give the tree 10 million liters of water instead of 100 liters of water.
Yeah, no, it doesn't.
And that is what happened a lot with all those startups. I think a lot of multinationals made mistakes with that. That they see a nice idea, they see something coming out of the ground, and then they think, okay, why not giving it 100 liters of water? Let's give it 100 millions of liters of water so it grows faster. And what you often see next is that the tree dies or that big troubles start to come. I don't say we did that better, but we were for some reason forced to do it a bit different, because we were carried by the government 50% by average. And so we all the time had to kind of proceed in the speed of the government, which is not that fast, with serious reports, with serious studies, with waiting for your money, or sometimes trying to get the other 50% of the money. And so from that point of view, we were able to stay alive today for 16 years. We didn't take big bank money into the company. We didn't take big investors into the company.
So you're basically still under control and learn how to work with scarcity. I mean, if you don't have a lot, you become very creative.
Exactly. That is what happened. Yes. And I don't say it is because we were doing something smart or a smart strategy or something. It was just, if you just get the money to pay your salaries for that month, and you're happy when you can pay them on time, your life is, like you say, it gets into a situation where you have to innovate, where you have to be creative, where it's not a matter of, hey, let's sit and stare in the sky and be smart. No.
No, but that's not how things work. I mean, you have to iterate as much as you can.
Yes.
To figure out how things actually work.
Yes, and then the good thing was that I think for that reason we could stay alive, and slowly the process became more mature. We could end up in pilot production. It still went slow. We had a lot of other subjects that we had to do in order to make the batteries not only land in Africa, but also in the rich West, so Europe, America.
And you mean then with legislation and compliance?
Legislation, certification. Yeah. You need the whole integration into the existing ICT and electronic webs and lines that are already there in society.
But that means that you have to make your own motherboards also, just to have.
Yes.
You have these salt batteries communicate with the system, which is of course different than a lithium battery.
Yes. If you talk about a serious energy storage system today in society, then you basically see 4 and soon coming 5 lines, five levels.
Yeah.
The bottom level is the chemical level, which is, you should have a good chemistry that is stable, that is good, that's powerful, that is clean, green, and so on. Then you have the connection to the outside world, which is usually still electronics, cables. If you line them up with existing governmental grids, you have already a lot of rules and regulations to pass, but it's an electronic story.
Yeah.
And then today we all want to see everything in our iPhone or in our computer, and we want to be able to control it. So you come to the third level, which is ICT and computers.
Yeah.
And then in the fourth level, you get data storage. You get it's kind of related to ICT. And then in the end, people always say, we want to make money with that battery. So what about the fintech? What about how do we sell our kilowatt hours when we can store them? And should we rent out batteries? Should we sell batteries? Should we sell kilowatt hours? Should we, make contracts with people?
The business case, yeah.
And that's the business case. So you need tech more or less on 5 levels in the Western world. In Africa.
Yeah, definitely for sure. Yeah. In Africa, you can just start and figure it out along the way.
Yes, and then we saw that, playing with our batteries on the basic level, on the chemical level, was always my hobby and probably always will stay my hobby. But if you really want to make it in society, it's not only a matter of economics and money, but it's also a matter of connecting different people with different expertise, with different experiences to each other. And there's a big difference if you make a chemist talk to an ICT programmer. They speak a different tongue. They speak a different language.
There's completely different countries.
yes, different countries, and they have to connect. And this also takes time, and this also takes patience, and this also takes the willingness to understand on content level what ICT people are doing or what electronic people on content level are doing.
But that also means that you need in manpower in that regard also multi-topic personalities that actually can shift between different disciplines.
Yes. And then on the side, you have the mechanics of the story, the mechanical engineering of the boxes, the systems, and the production of it, which is robotizing and the world of all of that. So it's an interdisciplinary technical area where you say, okay, if a chemist has a nice idea with a reaction in a beaker of water, he doesn't realize it yet, but to make it land in society, you need 6-7 different high-tech people to collaborate. And that is another issue, not when your name is, I don't know, a big company like, I don't know, Microsoft or whatever. They do it, all those things in a different way. But if you're a startup, you need to go from the scratch into a collaboration with 6-7 different disciplines, with just a little bit of subsidy and some few customers, then there's a high wall, a high mountain that you have to climb.
Yeah, and you're balancing on a very thin thread.
Yes.
But then again, that is about innovation. Are you capable of A, finding these people, and B, let them work together? And iterate very fast to come up with new solution directions.
Yes and no. What happened in our case was that we did connect to all those people, but as all those worlds are more or less new for us, you create teams that are not funded, not subsidized, not sponsored, and you need to work. You need to make a group of people work on it, with always the question for each of them where to get the money from.
But that's also typically a European issue.
Yes, but
and much less of what in other continents are happening.
Yes, but what you also see, for instance, in the multinationals, you see that things are always organized top down. That means a manager upstairs says, "Okay, we got a pocket of money. Now let's get the people and let's do it." But very often they miss the spark of innovation, or they miss the techno profit, so to say, that really has the vision how to go. And what you see in the country of technology is that very often profit is either being slaughtered, or the profit says, no, we should work bottom up. You guys should all listen to me. You should keep your mouth shut, because I have the vision. I have the view. Follow me, and I will lead you the way, which is for a lot of people already difficult to do. It's a difficult step, but even if they do, you get the all daily question, but how we get our money?
Yeah.
So this is the world of startups that go interdisciplinary, that go broader, that come with complex products. And purely from a technocratic point of view, I think this is why a lot of those companies don't make it, especially when they have a lot of bank money or a lot of risk capital immediately in from the start, given by people that want to earn back their money within a few years.
Yeah, that doesn't work. That money is not patient. It's very impatient funding. Yeah, but then the road you're walking, Marnix, there is a saying steady. I don't know which one it is, but it's just moving gradually forward and making progress.
Yes, we moved on all the time, and we were very many days that you think, what am I doing? Why should I just quit the road?
Then comes the question, why did you choose salt? I mean, sea salt. I mean, batteries are always salts. I mean, lithium is a type of salt. Lead is mineral, so that's different.
Yes.
What is the lead battery?
It's also a salt. Lead sulfate is also a salt, yes.
Oh, really? I didn't know that.
Yes.
That's something I've learned today. So, I mean, and moving to salt, I mean, it's abundant, but is it pure? Or I mean, sea salt, no. Sea salt is like...
Yes. Yes. In those first years of R&D, we developed 3 to 9 new chemistries, and in those chemistries, we saw that one chemistry was possible that used sodium chloride or sea salt, not just a salt like lead sulfate or lithium iron phosphate, but a sea salt from the sea, as a main component.
SaCl, yeah.
Sodium chloride, yeah, it's the salt we eat on our eggs, in our pom chips, on our fries. So it's a clean, edible salt that is healthy, that is abundant. It's everywhere in the world, at least in the sea. And then we realized, okay, let's go for the battery that use that salt as a main component.
Yeah, because one thing that came to my mind, and now I'm flash backward years ago when I was traveling around the world during my MBA, I found inspiring concepts of people taking literally sea salt, putting that into a cup, and then with an anode and cathode, and they actually could run a lamp on that.
Yes.
And it was, I think it was India or an African solution.
Yes.
For just to bring light.
Yes.
With an abundant mineral.
Well, it is possible. It's not that difficult. People that have good education in their secondary school already learn how to do it. It's not miracle science, but what is miracle science is to come to a product that can make it from many demands perspective really into society. So to say it in other words, a good battery needs to live forever. A good battery needs to have green materials. A good battery needs to be discharged 100%. A good battery can be used in any temperature that we want to use it. And a good battery can be produced fast, simple, easy, cheap. And a good battery can be recycled. So while saying this, you suddenly realize, wait a minute, that's already 6, 7, 8 demands that you put on the system. So
sustainability by design, yeah.
Sustainability by design. And so we got a lot of apps and people sending us, a battery that was made from a potato or a guy that put 2 copper pieces in water or whatever. And there's a lot of ideas.
Those I have seen already, yeah.
Yeah, but still, if you take the reality of society, then you basically see 2 batteries, which is only lithium and lead acid. So these are good batteries. They did make it to society. We shouldn't be blind about that. They have negatives, but they also have positives. However, there is also a darker side coming there, because especially if I see the predictions for lithium, I do see that the whole world wants lithium batteries and the whole world wants to drive electric. And the predictions for the easy to extract lithium are not that it will be totally abundant.
Yeah, I saw a presentation a couple of weeks ago that actually the prediction was we will never ever were able to substitute all the cars in the world by electric cars purely because there is not enough lithium available.
Yes, I saw a similar presentation by the European Commission, and it was 2030. They said there will be a gap coming. And also, the best way to measure that is simply take a look at the lithium prices. And you did see that they go up and down, and they were reduced a bit again lately, but they did increase a lot. I think in the years of 21, 22. And you see these heavy fluctuations. And for that reason, you see also now heavy investments coming from the governments, from China, to set companies that will produce an alternative for the lithium battery.
Yeah, and that is imminent. We need a substitute for lithium, or at least a second type of battery, because lithium will not drive it.
Yes. And then on the other side, there was also another, to go further with your question, we were also working on the subject of solar desalination.
Mm-hmm.
We realized that if you take seawater, that there is an endless amount of it on Earth, and when we realized we could make batteries with the salt from the sea, we realized we could also purify the water out of it. So in countries like Saudi Arabia, also in Israel, Ashdod, there is a giant seawater purification systems that make drinking water out of the sea. So we started to see that using solar desalination combined with the world of batteries is a perfect combination, because if you process the seawater, you get salt for your batteries and you get water for your drinking need.
Very high density salt, the brine is even toxic in that concentration.
Yes. So
basically, your input stream is a waste stream from the desalination plant.
Yes. What happens to most desalination plants is that they throw back the salt into the sea, which is okay to some extent, but there is sometimes troubles that the local ecosystem is already suffering, because you get a very high salt concentration on the local level. So yes, we do see it's better to put it in a battery first, store your solar energy, store your wind energy, store your solar energy.
Yeah.
And once the battery does end his lifetime, recycle the battery and either bring the salt back into the sea or use it again for the next battery.
Are you then also adding some chemicals to it, just to make the
No, we also add additives, salt additives, which is also again innocent additives, salts, and that helps to avoid, for instance, the formation of chlorine gas, because if you put just 2 electrodes in seawater and you put your volt on, you probably get hydrogen on one side and you get chlorine gas on the other side, and we don't want the chlorine gas. The chlorine gas is dangerous and toxic.
Wait a minute, Marnix. When we are going to produce hydrogen with electrolyzers, we'll also produce chloride.
If you do that straight in seawater, yes, you get chlorine. In the current electrolyzers, you would. But for that reason, electrolyzers do not use sea salt, but they use sodium hydroxide or potassium hydroxide, which is a derivative of the chlorine alkali industry, the salt electrolysis industry.
Just a side topic. How do we produce hydrogen? We need water for that, but water is H2O, but there is always salt in water.
Yes.
And most countries are putting them next to oceans.
Yes.
So you basically need to desalinate the water before you can produce hydrogen.
Yes. In most cases, yes. But another way to approach it is that you say, where are the biggest electrolyzers right now in the world? They are, according to my knowledge, at the sodium chloride industry, at the salt industry, basically, because in the production of chlorine, you electrolyze salt. You electrolyze salt water called brine. So there is electrolysis is being done with salt water, with brine, but then the main target is often not to make hydrogen, but the main target is often to produce chlorine that you can sell. If you say, now let's do that to make large amounts of hydrogen, then most people will say, well, it's not a way to go because we get too much chlorine gas.
Yeah.
So it's sometimes seen as an advantage in the chemical industry, but it's in most applications in the world, they don't like to see the chlorine gas.
Interesting.
And for that reason, they change from sodium chloride into sodium hydroxide or into potassium hydroxide.
Yeah, that just puts the hydrogen transition in a completely different perspective. That they're not talking about all the negatives and where they're extracting the hydrogen from, what type of water.
Yes. Another point, for instance, what you see in the world of hydrogen is that if you take a classical electrolyzer, a lot of people also don't realize, but for every kilogram of hydrogen you produce 8 kilograms of oxygen. So if we scale up the current electrolyzers, not to a megawatt scale, not even to a gigawatt scale, but if we say we scale it up way further, we blow a lot of oxygen in the atmosphere.
Which then also becomes toxic at a certain point because
at a certain point, yes, you start to yes, you get hyperventilation and all this kind of things or hypo in ventilation. But in that way, there's a risk that you don't get a CO2 crisis, but an O2 crisis, which is not today. It's not coming in the next 5 years, but in your R&D and your science, your development, you need to take that into account as well.
Yeah, definitely, Anders. You have another unintended consequence.
Yes.
And you also have the chlorine, which comes free.
Yes.
And if you don't put them to use, you're just producing more waste streams for just one material, for one molecule.
Yes.
You want to.
Yes. So this is why I'm saying it's very important before you innovate that you make a very good start. A lot of people say you have to do a feasibility study, and when the feasibility study is good, you do a project, and then if it's successful, it becomes a business.
That's a linear way of doing business.
Yes, and very often we say, well, you should not only do a feasibility study, but you should also do a visibility study. You should take your time to make a dream or a thought or a fantasy or some knowledge in your mind. You should get the time to make it land on Earth in the proper way so that you do the right feasibility study.
Yeah, in my point of view, I call that systemic. Do you understand what's coming out and what's going in and where it comes from? And
yes.
Do you already have solutions for the products that already are coming out of it?
Yes.
And most people focus on one product stream.
Yes.
As a potential value stream, whereas maybe the waste stream is more valuable than actually the product you want to extract.
Yes, you have to think today immediately about the waste stream.
Yeah.
Before 10 years ago, there was only one question coming to us. Do you have a business case?
Yeah.
What is the business case? Are you sure you can make money this way? And lately, people start to realize, okay, money is a big issue. It stays a big issue. It will always be a big issue. But we do see the big amounts of plastics in the ocean. We do see all the dirt and the garbage and the crap everywhere, and the fact that rainforests are getting smaller, and that there is a change in the amount of scarce materials, and that we have to take care of planet Earth as well.
Yeah. So so coming back to the fact that you chose salt for a more as the more systemic solution, because lithium will not solve it. I'm really curious, because I've read also articles about anodes and cathodes, because they are extremely important in a battery.
Yes.
And some of them already said maybe we should go to mushrooms, the mycelium of mushrooms as a good anode and cathode. So you also see that from a biological point of view, that they are looking for non-mineral, metal type of solutions.
Yes.
How has your research been on that area?
Now we went a similar way. We didn't go to mushrooms, but we did go to something similar, which is carbon. So we investigated, I would say, for many years, all kinds of carbons, graphites. Carbon, you can convert carbon into graphite, which is in the pencil of that we all have in our hands when we make a drawing. So graphite is a big issue. Carbon is a big issue. The pre-oxidation of those carbons is important to avoid corrosion or to avoid the erosion, deterioration of your carbon. And so that is an issue, yes. And carbon, why is carbon so important? Because carbon is a relatively cheap and stable material that can, in many applications, survive the problem of corrosion.
And corrosion is due to oxygen?
Yes, the oxidation of metal. If you take iron, we all know that it can rust. If you take aluminium, we all know that it can get some color, or that some oxides are being formed on top. And this is this you don't like when you develop a battery.
And with carbon, the electrons can move very quickly through them?
Yes, carbon has another big advantage, of course, that it does conduct electricity. And yes, it's crucial, of course. It needs to conduct your electricity like a metal. It's not as good as a metal, but it is good enough for a battery. And if you take a look at all those aspects, you immediately have to think also in a global way. We start looking where is most of the graphite being produced right now in the world, which is China. What kind of carbons and graphites do we need?
Yeah, well, because is it still wood-based? I mean, tree-based, plant-based?
No, the biggest graphite mines, according to my knowledge, are in China. There's also graphite in Sri Lanka and Africa. There's some graphite in other places as well, but
that's mined. I thought you made graphite. I mean, from I don't know.
No,
you use wood and you turn it to charcoal, and charcoal turns into graphite.
That's also true. There's basically two different graphites in the world. There's the artificial graphite and the natural graphite. Natural graphite comes from the ground, from mines, and the artificial graphite is being processed from. You could even do it from a mushroom, basically. You pre-oxidize, in general, a polymer, and that polymer is what you call carbonized, pre-oxidation, carbonization. And after the carbonization, you can graphitize it at 2,500 degrees, which is done in big furnaces, also very often in China, but also Germany and also other countries are good in it. But it's also an issue. Yes, so batteries are generally made from both graphites, but the natural graphite is lower cost, and it is preferred, I think, from a cost perspective.
Yeah, that's something I learned for today, Marnix.
Yes, it's everybody has a job in this world.
Yeah, true. So coming back then to your, in this case, the battery development. I mean, the strategy is clear. I mean, from where the need is to have substitutes for lithium, and so it seems to be a good point.
Yes. Yes.
What are the next challenges? I mean, how do you get the concept into a technological manufacturing concept? I mean, how do you turn a prototype into something that actually works? I saw some of your batteries on YouTube.
Well, we didn't do a lot of publicity in the last years, but we did a lot of pilots with boxes that we produce. Handmade production, and we do pilots, and we put pilots at municipalities, at houses, at farms, at solar panels, and we had a lot of years where we developed, let's say, between 2014 and today. We spent time on integration into the existing electronics, ICT, data world. Pilots grew more mature. Became more serious, and in the meantime we kept on researching the chemistry, improving the chemistry, and we ended up with a battery that can charge more than 50,000 cycles, which is 10 times longer than lithium.
Okay.
And actually we never saw an end of the battery, so we think it lives forever as long as the package stays closed and the water doesn't evaporate. It's a very stable chemistry. It works. It's nice, but
it doesn't catch fire.
No, it can't. It can't fire. It can't burn because water can't burn.
Yeah.
So it's a nice system. But we got the pilots. We now try to speed up the hand production. And in the meantime, we had numerous ideas for, also more high power type batteries for the car industry or for more lightweight applications. So there's developments, R&D going on all the time.
Yeah, that space is moving very fast. As you mentioned, a lot of national governments are pouring money into these sodium flow batteries. Yes.
But there's what you see now is that you get, everybody's waiting for basically two things: a low cost, abundant material, mass produced, clean, green battery for solar energy, wind energy. That's one group. And then the second group is the people that say, we want to have the best battery in our cars, in our lightweight applications, which is a replacement of the lithium battery. Now, you see that since 2020-21, there's a Chinese company, it's the biggest battery producer in the world. They spend massive energy to come with that alternative battery for lithium. I don't know details, but I do see that they are still also kind of struggling to pass that level in reality. So there's still a challenge there to go. The ultimate high power 300 watt per kilogram battery that is non-lithium is not there in the shop yet.
Yeah, but that means that lithium can store a lot of electrons in its molecules.
Yeah, lithium is a very nice material because it's very light. It's the lowest. Yeah. It's after hydrogen. It comes very early in the periodic system of elements. So this might. Yes.
So it's light and it can store a lot of electrons in its how do you call that? Sphere.
Yes, per kilogram, yes. Although the reaction of lithium is only a 1 electron reaction.
Oh, really?
While other metals can do 2, 3, 4 electrons. So there is alternatives possible for lithium. Although, again, setting such a battery on a level of mass production, developed in a bottom-up way that can really land in society the way it should land in society, is still a difficult path. And this is also why those multinationals 10 years ago went broke. Because they found out, wow, that is not an easy exercise. I sometimes joked that I said it's probably more easy to send a rocket to the moon than to set a new battery in society.
Yeah, because there is so many different levels, and to get a stable chemical reaction with extraction and input of electrons.
Yes. But I do believe it will. There will, in 10, 15 years, there will be this very good alternative battery. We have to. And there will be also this abundant, big scale, rolled out, lower energy density level battery for solar panels for wind energy. So it will come. But there's a third road that is going to come, and that is the world of green fuels. Because, a lot of people say, we have to get rid of CO2. We have to stop burning oil and gas. And then other people say, well, it's not a big problem. But the reality is that we are all addicted to oil and gas.
Yeah, the combustion engine has been very efficient.
Yes, and we buy it every day at the gasoline tank station, or we use it when we heat in our houses. So we're all stuck to it. But the battery of the fuel brings CO2 as a waste product, and we don't want that. So there's another big area coming and already running, basically, where people say we need to go to alternatives for the heating and gasoline industry. And also there we see a very beautiful road where we think that the world can go, and there is a solution for the CO2, and it is not that difficult. But again, it is a bottom-up innovation cycle.
What is the third route then? I mean, what is the alternative?
Well, what you see right now is that a lot of people say, okay, you know what? We take the solar panels, we take the windmills. Let's use the electricity to make hydrogen gas.
Yeah, but that has such a big energy loss.
There is a loss, but it is doable. It is possible. Although it doesn't have yet a very strong business case, but if we want it as a world, we can do it. However, there is a gap between producing hydrogen and making electricity back from hydrogen.
Mm-hmm.
So there's a gap between the production of hydrogen and, so to say, the storage of hydrogen and the conversion of hydrogen.
Yeah, and conversion, you mean from hydrogen into electrons?
Yes, for that you need a fuel cell. So you see in most applications in society, you see that you need 3 systems, which is an electrolyzer. You need a storage system, and you need, which is generally a high pressure system, and you need a fuel cell. So you need to buy 3 systems with efficiency loss in every system in order to use electrons from hydrogen, which should be used maybe at night while the solar panel is making the electricity in the day. So there is a gap. There is a difficult area to go on that spot. However, there is also new ways to convert hydrogen into green fuels.
Hmm?
And those green fuels don't blow out CO2. So we also do believe that there is a road coming where we do jump back to our old gasoline stations, not filled one day with gasoline and oil, maybe for the next coming years, but one day I think they will be filled up with green fuels, with fuels made from hydrogen and CO2 that will be used in the cars.
Help me out. Hydrogen and CO2. I think I'm then thinking carbohydrate kind of molecules, CH type of molecules. But
sorry. Yeah, it's a big monologue now. But
no, it's a big jump. So let's
go back to school class. In that case,
on hydrogen we cannot run a car. That requires so much hydrogen to have it.
Yes, you need a lot of hydrogen. You need a high pressure vessel, and then you need a fuel cell. It all costs money. You lose efficiency, and it is doable. Toyota did it for some time. We started with it 100 years ago. Also, it works, but it doesn't go as easy as a lithium battery put in a Tesla. So for now, the lithium battery Tesla road is a logical, road that we need to go. But it's a matter of time, and then people will set the electrolyzers, and they will do the straight conversion of electrons coming from solar panels and windmills into not only into hydrogen, but also into alternative molecules. And those molecules will not produce CO2.
Mm-hmm.
And that will also help us to go green and clean. And I do believe that the CO2 level will go down in the atmosphere. It might take 10 years, 20 years, 30 years, but it is doable. It needs time, it needs R&D, it needs investment, but it is doable.
Is that your glycerol fuel cell? Glycerol?
No, we worked in the past on a glycerol fuel cell. It's a nice product, but that's not. We have another one that we work on.
But one thing that is not filled in my mind is okay. You have hydrogen and then an alternative fuel cell. What is the storage medium then? What is that a salt?
A very well-known example that people always give as alternative to hydrogen is ammonia.
Oh yeah.
Ammonia is there's a company in Israel. It's called Gensel, and they already make ammonia fuel cells. And they say if we are able to convert solar electricity and wind electricity straight into ammonia instead of hydrogen, then we have the green world nearby, because
that also has a higher density than hydrogen.
Yes, it's an interesting molecule because it's a liquid and it's not a gas. However, there's also quite a few others. We see about 3-4 new others next to ammonia coming, and we do think that at least one of them will make it big in society.
And that is not methanol, for instance?
Methanol is one of the options, but methanol also had a big advantage in the past. Why? The Germans did very good work in methanol. Company like Siemens, Westinghouse did great projects there in that area, and we came very far. But there was also a time that people started realizing, wait a minute, if we make methanol, we put it in a fuel cell, we still get CO2 out.
Yeah.
And then methanol went down again. Because people said, okay, methanol is probably not the road, but let's try ammonia, or let's try another one.
Yeah, because I'm mentioning methanol because Maersk is equipping their container ships now with methanol fuels.
Yes, it is an interesting development, and we shouldn't let it go. We should work it out, but
the exhausts the emissions are still CO2 then.
Exactly. So the strong alternative fuels for today are hydrogen, ammonia, and we see another 2-3 coming, which we work on.
Can you mention them, or is that a secret? If it's a secret, it's a secret. I mean, I'm just curious.
I give you one tip of the vein. I think I don't know if I can say that in English, but the one that we work on, or the few that we work on, are based again on salt water.
Okay.
And mixed with additives, and in that way we try to generate a fuel that is. You cannot burn it. It's clean. It's green. It's you can use it in a fuel cell. It will not bring CO2, and it is doable. And recently we got an R&D project for it to make it more mature.
Yeah. Okay. Cool.
So we do hope that we can come not only with a sea salt battery, but also with this alternative fuel cell.
Yeah, and basically, the deeper you dive into salt, the more application you start to find.
Yes.
In that way. I mean, that's sort of like you start with sea salt batteries and now fuel cell, and you even have cooling with salt concept.
Yes, that's another area. Yes, you have the whole area of, for instance, all those absorption chillers. They use bromide salts. They are taken from the sea or from the bromide deposits. But it is a salt-based technology. Chillers, absorption coolers, yes, they can also be set with salt water with salts. So there's a lot of power in the salt. And
because you also have the phase shifting materials, which is amazing that they buffer the heat.
Yes, it's also salt-based. Also salt-based. You have all these different PCM materials, and they have a certain melting point range, and when you have the right one, you can store heat in it and release heat. We know a company that make panels. That's making panels that store heat. So yes, salt and water are very powerful ingredients to set the whole new economy. We do not only depend on the oil and the gas, although I'm happy we do have oil and gas today. Otherwise, it would be very cold in winter.
Yeah, the reason I was just laughing a little bit was that salt and water is the base of life. So I still see a circle back to the origin of life. And once we understand salt and water in much more profound way, we can start finding actual solutions for them.
Yes.
I was yesterday on an event, and there was a research company specializing in applying artificial intelligence for research. I was just curious, are you applying artificial intelligence to figure out areas of possible solutions? I mean, you have your sort of your criteria and your challenges, and is AI helping you to find sort of in your matrix to fill up the white spots? Just out of curiosity.
Practically in the brain, to some extent, it did with us in 2008, 9, 10, 11. But we are not developers of AI technology, and we are not on the front edge of AI technology.
No. It's not. It's more like, are you using AI to find solutions for the problems you face?
Well,
sort of like from a TRIS perspective.
Yes, AI for us pops up not in screening the periodic system of elements and trying to find the best battery. Mm-hmm. I don't see the application there, at least in our case. But we do think that AI will probably come up in the whole world of microgrids, in the whole world of energy predictions. Mm-hmm. Because what you see today is that a lot of people want to take a look at the weather, and then they see tomorrow the sun is shining, and the technocrats among us will immediately say, okay, then tomorrow at 12 o'clock I will get this much of kilowatt hours from my solar panel, and I will sell it for this price, and I will make money as much as this or as that. So people do like to predict their budgets and their kilowatt hour production for the day of tomorrow or the week of next week. There's a whole energy stock exchange today where energy is being traded to the IoT, to the Internet of Things. And in that area, it is an advantage if you can predict from the weather the energy market. This is one area. The other area is that, if you're in the middle of Africa and you're in an off-grid house and you say I have 5 solar panels and I need a battery, well, that's an easy job to do. But if you go to a city like New York, where you have skyscrapers, where you have a lot of buildings, people all crawling around, and they say, wait a minute, we need to implement in our whole existing infrastructure of electricity, electric cars, batteries, fuel cells, green fuels. People freak out because it's really hard to calculate it on a larger level, on a macro level. You can make very big assumptions and then you can do quick calculations, but we did see in reality, if you want to develop and implement those systems in a larger scale in those areas, that you do need AI and advanced computational dynamics and ways to get it integrated in a proper way. Although as a chemist, I do also keep saying, do not only calculate, keep measuring and use real data to control the predictions that we do with AI. So AI, yes, is going to grow. It's going to be bigger. It can be used in the world of energy. It can be especially used in the world of prediction of energy prices and amounts, and also in the integration of systems at lowest cost in urban areas. Their AI, I believe, will have a prosperous future.
Basically, we need artificial intelligence to streamline the highway of electrons. Otherwise, it becomes a mess.
Yes, and also next to connect the financial world, the Bitcoin, the stock exchange markets, the Internet of Things. Everything is being integrated with everything today.
Yeah, and I didn't realize that for energy systems that software is such an important aspect. I thought it just, as long as that's at least the lesson I still remember from my high school, as long as there is a voltage on the lines, there is supply. But
yes,
of course, if demand is higher than the supply, then the whole system collapses because it's extracted faster than you can put it on the net.
Yes.
But I never realized that you need software to control the flow of electrons to make sure that the system doesn't break down.
Yes. Well, there's whole groups in universities having big computers trying to simulate everything that's going to happen on the grid. And also very often I see these people being frustrated because they end up in a computer island with smart mathematicians, far from the reality of a guy that is just making a box with salt. So there is gaps, and all those technicians and scientists are not always, I would say, the best communicating people, or maybe they are, but they don't always have the time to do, let me say it that way. And so in the current world, they need to communicate to each other.
Yeah.
And one speaks Greece, the next one speaks Arabic, the next one speaks Chinese, or, the mathematician speaks a different language than the ICT guy, and the ICT guy speaks a different language than the chemist, and the chemist is on a totally different level than the robotizer. So yes, it's not always easy.
Would you see the energy transition is an example of where multidisciplinarity is put on a magnifier glass just because we need to reinvent actually how we produce, store, and transport electricity?
Yes, basically that is what is going on, and it happens because we want more and more and more electricity, and we don't want the CO2. So we put two very heavy demands on the current electric situation.
Yeah.
And we are all responsible for that. We can all blame each other. We can be left wing, right wing.
No,
green,
but it just means that we started too late to rethink our electricity system network, because it's something you could foresee if the demand for combustion lowers and the demand for electrons increases, your infrastructure will get stressed.
Yes.
Then I need to ask you this question. What is the benefit or disadvantage of direct current versus alternating current? Because I know that solar panels and basically renewable energy is all direct current.
Yes.
And direct current is easy. Conversion to alternating current is always an energy loss.
Yes.
We go up and then at home we go down again, and then your laptop brings
Yes.
it back to the same
Yes.
voltage as the solar panel.
Yes.
Can you give your perspective on that?
Well, it's very obvious that DC is going to be more and more important. That's for sure, because we do get more windmills and more solar panels. And indeed, following that development, it is logical that we have to kind of make a big reset in our minds, that things are not only coming from gas and a turbine and an AC current, but things are starting from a DC current. And somewhere in between, they have to meet each other, because by far most appliances and applications do use AC current. There's a lot of people say, make everything go DC. There's also the sitting people that say, no, we stay with AC for the next 50 years. Keep your mouth shut, so to say. But the force, the power that is giving pressure from for the DC perspective is increasing, is growing. So I do think that going the DC road is a smart road. However, let's stay with both feet on the ground and be realistic. You also have to be honest. I'm not an electrician, but I do know that DC current, at least they say that in the Netherlands, is more dangerous than AC current. So there's also reasons to say, let's stay on AC for a while. But yes, you cannot circumvent the fact that there's more and more solar panels, more and more wind energy, and that is DC. So, and it is indeed unlogical when you charge your electric car with your lithium battery, which is also DC, to go, in some cases, 2-3 times AC/DC. So I think there's also changes coming on that area in the coming years.
Yeah, okay, but it's just because there is so much inefficiency and you lose so much, then you wanna if there is a shortage of so much, then you want to become much more efficient, and just cut the transformations in between out.
Yes.
Just to make sure that it goes easier from up to down. Wow, thank you for this small lecture on batteries, electricity, and chemistry, Marnix.
Yes.
It has been very profound for me. I've learned a lot today, and what But it's good to understand that the chemistry in batteries is much more complicated when you move out from a prototype to an actually product in a mass production. I mean, the examples of the salt batteries where you can draw light on is the low-tech solution.
Yes.
But you want a durable solution, and that requires so much more multidisciplinary know-how.
Yes.
Bringing that together and bringing that forward, I understand actually why you took small steps, and maybe even that is the smartest thing you could have done compared to the big guys, because you took time to figure it out what the most optimal direction is.
My wife and I, we got 3 children, and I sometimes joke that I also got 3 children. It's a water child, a battery child, and the green fuel child. So I always say I hope I can get 6 children into society somehow. And if I don't succeed, perhaps one of my children can do part of the job.
Yeah, so sometimes that happens. I've seen some examples of that, but it's not easy to step in the big foot of your daddy.
Yes. Well, yes, that's also true. I shouldn't put any pressure on them, but yes, this is the labyrinth that the life of an inventor in a scale-up phase is going in.
Yeah, and also your perseverance, and I think for most people, scaling up is also a life-changing event from a personal perspective. Because it's basically you have a 4th child, which is your company.
Yes.
And that has its own challenges and dynamics also within the family.
Yes, it is.
And I'm talking also from experience.
Yes. Well, generally you see the scientists work either in the multinational, in the university academic world, or in the startup scale-up. And I also see that, again, there's a plus and a minus for each scenario. But I do think product growth, initiation, startup needs to happen in the smaller companies, because universities have a focus to teach students and to produce papers and publications. Multinationals have the focus to go with existing things bigger into society. And so for me in 2008 there was no other path finally than to make the jump into the SME and the startup and the scale-up. And with all the risk it had, yes.
Then I wish you all the good luck, Marnix, and looking forward to what happens in the future.
Okay, yes, thank you so much, too.
I'm pleased you took time to listen to the whole episode. Why not consider joining my Patreon to support me in creating more of these conversations? Or even rate my podcast in your favorite podcast app. Thank you again for listening, and join me next time.